find the magnitude of magnetic field at the center of the arc. This is the center of the arc at P. See, it has got two portions. This is a wire portion. Current is flowing like this, and it will produce, the current flowing will produce a magnetic field at every point. Now we are interested to find out at the center of the arc. Say, let us say this is P. This is a point, that is A, B, in which current is flowing like this. See, Biot-Savart law, what it says, Biot-Savart law, dB in vector form, mu naught by 4 pi into I divided by R cube into dl cross product, dl vector cross producted with the R vector, where dl is the, see, let us take, this is a dl vector, a small portion of the length, dl vector, whose direction is along the direction of phi. It means dl vector is in this direction. This is the R vector. R vector means the distance of the point at which we are interested to find out. From this point up to the dl vector is R vector. So dl vector is in this direction, R vector is in this direction, and dl vector is in this direction. Then theta is equal to 180 degree. What is theta? Theta is equal to angle between dl vector and R vector. Because by Biot-Savart law we can write like this also, is equal to mu naught by 4 pi into I by R cube into I dl into sin theta. That is on expanding this cross product. So this R dl into R dl into R, this can be written as small amount of magnetic field produced, that is dB is equal to, in scalar form, small amount of magnetic field produced by this current element at this point is equal to mu naught by 4 pi into I divided by R cube into R into dl into sin theta. This is in magnitude form. On expanding this one, this is in magnitude form, and this get cancelled. So dB is equal to mu naught by 4 pi into R square I. This is theta. What is theta? Here theta is equal to 180 degree. Theta is equal to 180 degree angle between this. So sine of theta is equal to sine of 180 degree is equal to, sine of 180 degree is equal to 0, because one angle is this side, another angle is this side. The angle between them is 180 degree centigrade. So sine 180, angle sine 180 into sine of I into dl into sine 0. So dB due to portion AB at P is equal to 0. See, the magnetic field produced this length of the current at P is equal to 0. Similarly, this will be this for this length current element, for this length will be also equal to 0, because here the R vector is this is C, this is D, this is R vector in this direction, R vector, and dl vector, current is flowing in this vector, so dl in this direction. So R is here, in this case theta is equal to 0 degree, sine 0 is equal to 0. Therefore magnetic field at P due to wire AB and CD, B is equal to 0 and B is equal to 0. Okay, so this portion does not produce any magnetic field, and this portion does not produce any magnetic field, though current is flowing through this conductor. As it is, we have seen current flowing through a conductor straight path on itself is equal to 0. This we have already seen. Now we will see the portion BC. For portion BC, it is an arc which is, this is an arc which is subtending an angle of 30 degree with the center P. So we can take like this. This is the arc subtending an angle of 30 degree. This is R, and this is B comma C. This is B comma C. Arc length is equal to arc length of BC with respect to center is equal to the radius into the angle subtended. Okay, the length. So it means the arc length. So we can say DL. See now here, what is the angle between this? See that this is the radius vector, R vector, and this is the current element. The angle between them is 90 degree, because R vector is this way, DL vector is this way, current is flowing this way. It means DL vector is in this direction. This is R vector. Theta is equal to 90 degree, and sine in 90 is equal to 1. Therefore here we can substitute here, angle between DL and R is equal to 90 degree. Therefore dB can be written for the portion BC. dB can be mu naught by 4 pi into I divided by R square, this cancelled, into DL, because this is equal to 1. So this is the magnetic field due to the portion BC. So now we have to calculate what is the magnetic field produced at the B due to this element, due to this wire, and due to this wire in which the current is flowing. So we can write this, we can call it as B, dB1, or we call it as B integral. So we have to find out dB, total magnetic field. Why total magnetic field? We have taken the magnetic field produced due to the current element. Now we have to find out for the entire length. The entire length is equal to R into theta, as we have found out. So now B is equal to integral of dB is equal to mu naught by 4 pi into R square I into integral D, because we have to integrate only DL only. So integrated, so therefore B due to the portion, this portion, we are talking about this portion, B is equal to mu naught by 4 pi R square into I into DL. DL already we have found out, R into theta, because DL is equal to R into theta. Therefore mu naught I by 4 pi R into theta. In short form we can write mu naught I divided by 2R into theta divided by 2 pi. This is the magnetic field produced by a circular current element. So we have to put the angle subtended with the center. This is 30 degree. So now we can substitute this value. On substituting this value, we get the value of magnetic field produced by this element. So this portion B1, we call it as 0. This is B2 produced equal to 0. This we call it as B3, which we can call it as B. Therefore B, and substituting the value, mu naught by 4 pi. We know mu naught by 4 pi. Value of mu naught by 4 pi is equal to 10 to the power minus 7 numerical value. Mu naught by 4 pi, we can write mu naught by 4 pi is equal to 10 to the power minus 7 into current. Current is given 3 ampere, and radius. What is the radius of the arc? Radius of the arc is equal to R is given, this R is equal to 60 centimeter, or we can write 60 divided by 100 centimeter, 60 divided by centimeter. So is equal to 4 pi into 2, 10 to the power minus 7 pi into r is equal to 6 divided by 10. We can write 6 divided by 10 r into theta. Theta is equal to 30 degrees. See, 180 degrees is equal to pi. If you want to make it 30, divide by 3. This is 60 is equal to pi. The here also you have to divide by 3. Therefore, into pi by 3. So, magnetic field is equal to 10 divided by, okay, 10 to the power 7 into 3 into 10 divided by 6 into pi by 3. Note here you should not put the value of 60 degree. You have to put the radian value to get the answer. Therefore, the value of B I am calculating is equal to 2.62 into 10 to the power minus 7 Tesla. So, the magnetic field produced at the center of the segment due to this current flowing through this conductor, this is producing zero magnetic field, this is producing zero magnetic field at this point, and this portion is only producing a magnetic field of 2.62 into 10 to the power minus 7 Tesla.